Yes, hello grade 12s, this is Patrick Kamara trying to get to you. Now, if you enjoyed our previous video, I am sure you're going to enjoy this one as well. Today we're looking at summing the terms of an arithmetic series. Summing the terms of an arithmetic series, okay? Now, an arithmetic series, like you know, it has the consecutive terms have got a constant common difference. Ne? Okay, let us check. Now, an arithmetic series is the sum of an arithmetic sequence. In other words, if this is our arithmetic sequence, that is, as you can see, 5, 7, 9, 11, and so on, then its series is this one here. That is 5 plus 7 plus 9 plus 11 and so on. Okay, now note something that with arithmetic you've got a common difference there. For example, 7 minus 5 you get 2, 9 minus 7 you get 2, 11 minus 9 you get 2. So the common difference there is 2. That's why it's called the arithmetic. Now we will use the formula below to calculate the sum of an infinite arithmetic series. Okay, now this formula says that Sn equals to n over 2, open brackets, 2a plus n minus 1 times d, whereby this Sn, it means the sum of the first n terms. The sum of the first n terms, and then this n means the nth term, and this 2a, this a here means the first term, and then the d means common difference. N still means nth term. Ne? Now, if we have the last term, we can still get our sum of the first terms given by n over 2, open brackets, first term, then plus last term, okay? Whereby L is the last term of the series, and given by L equals to a plus n minus 1 times d. Now, you can say, how does it work? Now, where does this formula come from? Let's check it out. Take an example, example 17 here. Evaluate the arithmetic series, that is S8 equals to 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17. Now these are 8 terms. Ne? Now let us see the solution. We need to see how do we add this one here to get the answer when you add all those first 8 terms. How can you do them easily? Now you can write your first 8 terms, that is 3 plus 5 plus 7 plus 9 plus 11 plus 13, and then plus what? Plus 15 plus 17. Okay. Now, if you rearrange this and start with the highest, start with 17 plus 15 plus 13 plus 11 plus 9 plus 7 plus 5 plus 3. So after rearranging them, we can add 2 plus 17, we get 20. 5 plus 15 we get 20, 7 plus 13 we get 20, 9 plus 11 we get 20, 11 plus 9 we get 20, until the last one, which is 17 plus 3 is also 20. So check here, how many 20s are here? 1, 2, 3, 4, 5, 6, 7, 8. So in other words, it's going to be 8 times 20, which gives us 160. And because we added the two sums, as in 2s8, this s8, this sum of the first 8 terms is this one here, and another one, so there are 2 of them. That's why I've got 2 here. Okay, so this 2 means we've added 2 sums. So to get only the sum for the first 8 terms, we must divide the 160 by 2, which gives us 80. Okay, I hope we are together. Now, the above method can be derived the above method can be used to derive the formula for the sum of the first n terms of an arithmetic sequence. Now, this is a theorem here. Let us see how we state it. Let us see how we state the theorem. It states that the sum of the first n terms of an arithmetic sequence is given by the formula Sn equals to n over 2 into 2a plus n minus 1 times d. This is the proof here. We are going to say let the first term of an arithmetic series be denoted by a, and let d denote the constant difference. Okay, let us proceed. Now our first n terms, the sum is given by the first term plus the second term, that is a plus d, plus the third term, which is a plus 2d, plus many terms until the third last term, that is a plus n minus 1 times d, then plus the second last term, that is a plus n minus 2 times d, and then plus the last term, that is what? That is a plus n minus 1 times d. So this is my last term here, which is a plus n minus 1 times d, and this is my first term here. Okay, now like in our previous example, if I rearrange this and I get something like this. Now I begin with the last term, which was a plus n minus 1 times d. I start with it here, so I'm going to have a, okay, a plus open brackets n minus 1 times d. This is my last term. Okay, now followed by the second last term, which is a plus n minus 2 times d. Don't forget here, now this one, remember that is now in the descending order, until the first term, which is a, and the second term, which is a plus d. Now don't forget, our first term here, it was a. Okay guys, so we are saying that when we rearrange this same, then we are going to add the terms. Like I'm going to add a plus n minus 1 times d, and then I add a plus d plus a plus n minus 2 times d, then I add a plus 2d plus a plus n minus 1 times n minus 3 times d. Okay, so I'm going to add all the terms. Okay, now when I do so, this is what happens. So this is a plus n minus 1 times d. That's what I did for you here. I don't know if you can see this. So if I add a plus n minus 1 times d, this is what I get. Now a plus a is 2a. Okay, and then n minus 1 times d, it remains as it is. So it means my answer is what? It is a plus n minus 1 times d. That's if I add the first and the last term. Okay, and then check if I add the second term here, that is a plus d, then plus a plus n minus 2 times d. Check this out. This is a plus d, which I have here, and then this is now the a plus n minus 2 times d. Okay, now if I open brackets, I'm going to have a plus a, which is that's what you see here. Okay, are we together? And then there is a d here. Now this is d plus, now when I open brackets here, this is d times n, which is nd, and this is d times negative 2, which is minus 2d. That's what you see here. So I've got d plus nd minus 2d. What I do next, I correct like terms. So a plus a, I get 2a, and then this is d minus 2d, it gives me minus d, and then plus nd. So this is the nd minus d, which you see here, and this is the 2a. Are we together? Now the nd minus d, as you can see, it has got a common factor, which is d. Okay, so this is the outside here. So this is 2a, this is 2a plus n minus 1 times d. Now if you take this answer is the same as this answer which you see here. Okay, same as this answer which you see here. Now if I do this for all the consecutive terms, and I add them like in the first equation and the second equation, I get 2a plus n minus 1 times d. Now because my number of terms, they are n, it means I'm going to have n times 2a plus n minus 1 times d. Hope we are together. Now this 2 is because I was adding two terms, I was adding the two terms as I got the 2sn here. Okay, now because I'm looking for only one sum of the first n terms, I divide by 2, which gives me n open brackets 2a plus n minus 1 times d divided by 2. So this is how we derive the formula. This is how we derive the what? The formula of the first n terms of an arithmetic sequence. Now this formula here, they can ask it for you to derive in the test, so please understand how we will do it, but usually we ask about the application. So it is also possible to derive a formula to calculate the sum of a finite arithmetic series consisting of n terms. So the formula Sn equals to n over 2 into 2a plus n minus 1 times d can be expressed as follows. Okay, so sometimes if we have the last term, we can express this formula in a different way, but just to make things simple for us. Okay, now as you can see, this is 2a plus n minus 1 times d. Now the 2a, I can write it as what? As a plus a. Okay, as a plus a. And then this is n minus 1 times d. That's what you see here. Now if you remember what we said, this a, different color now, this a from here, this a up to this d here, the whole of this is what we call as our last term. So in other words, that is my L, which comes here. So it means if I have my first term and the last term, I can use the formula to get the sum of the first n terms of arithmetic series by saying Sn equals to n over 2 open brackets first term plus last term. Okay, let us look at some examples here. Find the sum of the first 20 terms of the series. Now you see here I don't have the last term, so okay, but I want the 20 terms of the series. So what am I gonna do? I need to find S20. Let us check it out. Now because I have the series, that is -1 plus 3 plus 7 and so on. What is 7 minus 3? That is 4. What is 3 minus -1? That's also 4. Which means that my common difference is 4. Okay, and my first term is what? It is -1. So because I have the first term and the common difference, then now I have to use the first formula. I said because I have the first term and my common difference, and I know I'm looking for the sum of the first 20 terms, then the formula works for me because it is Sn equals to n over 2 plus open brackets 2a plus n minus 1 times d. Okay, now I'm looking for the sum of the first 20, which means my n is 20. That means S20 equals to 20 over 2 open brackets 2 to -1. -1 is my first term, which is a, and the n is 20, and d is what? Is 4. Okay, so when I simplify this, I get 740, and I hope we are together. Now some questions, they can be like this one here. They say find the sum when the number of terms is not known. Okay, in the previous question we were lucky, they wanted the sum of the first 20 terms. So in here we don't know the number of terms, so they say find the sum when the number of terms is not known. So the question says calculate the sum of the following finite series, that is 3 plus 5 plus 7 plus so many until plus 111. So now this 111, guys, this 111 is my last term. So this is the last term here, and this is my first term, that's my a. I can get my common difference, which is 5 minus 3, that is 2. 7 minus 5, that's also 2, which means I've got my common difference, that is d equals to 2, and I have my first term, which is 3, and my last term is 111, that's 111. Okay, so what I do, because this is arithmetic, I first use the formula Tn equals to a plus n minus 1 times d. Then I put here 111 equals to 3 plus n minus 1 times d, which is 2. Then I can get my what? My n. Okay, I can get my n like this. Now if I simplify, I'm gonna get 3 plus 2n minus 2. Now this minus 2 What is 3 minus 2? 3 minus 2 is 1. So the 1 becomes negative this side. So 1 minus 1 gives us 110 equals to 2n. So divided by 2, it gives us n equals to 55. So in other words, there are 55 terms in the series. Now it means that in my series which I wanted to get has got 55 terms. So I'm going to use this formula. I can use this one or this one here. Okay. I'm saying that I can use this formula here, or I can use this one here, because now I know that the number of terms, there must be how many? There must be 55. Check this out. Now my n is 55. My first term was 3, and the last term was 111. So it gives me my answer as what? As 3135. However, if I use the previous formula, my n is still 55, my a is 3, and my d is what? It is 2. What about my n? It is 55. Again, if I simplify this, I get my answer as what? As 3135. I hope we are together. So that's what you do if you don't know the number of terms. You have to first find them. Another example, guys. Another example. It says that it says calculate the summation from m equals to 2 up to 100 of 7 minus 2m. Okay, calculate what? The summation from m equals to 2 up to 100 of 7 minus 2m. Now this one here, now this is in our previous video we said that this one represents summation, which means we're going to sum up all the terms from m equals to 2 up to 100. But if they give us such a notation, we know we can get our number of terms, right? Because we said it's given by the top minus bottom, then plus 1. So it's going to be 100 minus 2 plus 1, that is 98 plus 1, which is 99. Okay, all right. Now before we continue, we're going to expand this so that we can identify what type of series it is. Is it arithmetic or geometric or quadratic? Okay, now if I do this, I'm starting with m equals to 2. That's why I put here 7 minus 2 times 2 to get my first term there. Okay, and then when from 2 I go to 3, that's why I say 7 minus 2 times 3. Then I go to 4, that is 7 minus 2 times 4. And then I go to 5, that is 7 minus 2 times 5. And so on until the last term, whereby I'm going to use now 100. Now this 100 is not the last term, but it helps me to find the last term, which is our L in the previous formula. Okay, so now if I simplify this one here, I'll get my last term. So if I do this one here, as you can see, I'm going to get 3 plus 1 plus negative 1 plus negative 3 plus so many until plus this one here, it gives me negative 193. So if I check this, I can see that my first term is 3, the second term is 1, the third term is negative 1, the fourth is negative 3. So I can check it out. If I say 1 minus 3, I get negative 2. And if I say negative 1 minus 1, I get negative 2. So you see, because I get negative 2 as my common difference, it means this is arithmetic. This is what? This is arithmetic because the common difference is minus 2. Okay. Now, the moment I know that it's arithmetic, then it means that now my formula can apply to get the sum of this series. Okay. Whereby the last time is what? Last time is negative 193. Now we said that we must know the number of terms. By the way, we said you said the top, that's 100 minus lower, that is minus 2 plus 1, which gives us 99. So it means we're looking for the sum of the first 99 terms. Okay, so Now I can use any of the formula because I have all the information I need. If I can use this one, this is a plus last term, I can just substitute here. Or I can use n over 2 plus 2a plus n minus 1 times d, and then I know my d is negative 2, I know my a is 3, and my n is 99, so I can get my answer here by substitution. Okay, even here I do the same thing here by using the last term, which is negative 193, then plus the first term, which is 3. Okay, then I simplify, which finally gives me what? It gives me negative 9405, which is the same as this one here. I hope we are together. If we are not together, please pause the video and watch it again. Let us proceed. Now this one we shall do it tomorrow. Now after this we have an exercise to do. Try out this exercise, this one here, up to question 5, and when you are done you can check your answers on this next page here. These are the answers here. So thank you so much for watching. Catch you again in my next video. Bye bye.